Hello, my name is Lamoy Augustus, and this is my demo for the final. And I just want to explain my inputs first. Um, the inputs are these two switches. I understand that during the description said to use a button for the reset, but as much as I could modify my code and adding an inverter component or anything, it still would not work as function. The reset button would act as if it was always clicked. So the clock would not be blinking or activated at all. So I resorted to just using a switch. So the inputs are these two switches where this switch is the input pin, and this switch is the reset. So first I'm going to just add in one correct sequence and then just reset it, just to show that the reset works. So it's reset, and when the reset is on, the clock signal is disabled. And just to rant a bit more on my troubles with the reset, I tried an asynchronous one, a synchronous one. I tried doing it in another process separate from the clock, but that didn't work. I kept getting errors, so that is why I'm using a switch. So I'm going to go through the simulation request. So first, for the demo, first we want to reset the system, which we have already done, and then we want to enter various values so the sequence is entered correctly and incorrectly. Ensure that the count increments upon correct detection. Do this several times and explain what the input is and what the result is. Ensure video can be seen clearly, yada yada yada. So, and this is how our FSM is set up. So, we are in the 0 state by default. I forgot to add the reset, but we're in the 0 state by default, and when we enter 0, we are at the S1 state, and then 0 again, we're at the S2 state. One thing that is somewhat maybe an issue is that whenever we okay, so right now, let's say we are at the 0 state, right? So we entered, I'll reset it, and then I'll start 0, 0, 1, then it changes to 1 on the next clock signal. And that's just because it's detecting that the sequence is complete at the same time that the counter is getting the output from the FSM component. So that causes it to happen, the change of the 7-segment display, the output from our segment decoder to change on the next clock cycle. So first we're at the S0 state, and then we go to the S1 state, S2, then we go to the +1 state, and we unconditionally go back to the S0 state on the next clock signal. So that is how our inputs are set up. So right now we have one in, we're going to reset, then we're going to input 0, 0, 1, changes, 0, 0, 0, doesn't change. Just let it input weird things. Inputting ones, it doesn't increment. Now 0, 0, 1, I missed the input. Oh, my bad. It messes me up too, because you would expect the change to happen on the correct clock cycle, but a solution A solution I had is to use two different clock dividers, one that's operating at a faster time for the FSM than it is for the counter, so that we can get the output from the FSM. Well, I'm not sure if that'll actually work, but maybe get the output from the FSM a little faster to the counter so that it has time to make the right decision and send it to our 7-segment display or 7-segment driver. So then 0, 0, 1 changes, 0, 0, 1 changes, and doesn't change. And I think that's enough times to input it correctly and incorrectly, ensure that the count increments on a correct detection. So we'll just go ahead and reset it and do it one more time. So at a reset, 0, 0, 1. Zero, 0, 1, change, 1, change, 0, 0. Okay. So 0, 0, 1, change. Oh, I keep missing these. Yeah, so I feel like that's enough times. Go ahead and reset, and that is it for my lab. And I gotta say, this is probably my most, even though it's frustrating at times and trying to meet deadlines, this is my most enjoyable class. So thank you for teaching me. Bye.